Hello, students. How are you? I hope you're fine. That is our sixth lecture. And in this lecture, we will start with the topic dynamics. I have said that in the previous lectures that technically speaking, the first topic or the first section of the mechanics was kinematics, in which we have studied the bodies in motion and what are the physical quantities associated with that. Now we will see the reasons, we will see the attributes, I mean, the things which cause the motion. So, the first thing we're going to start in this lecture, that will be Newton's law. Newton's law of motion. First of all, the important point is there are three Newton's law. You already studied that. If you don't, we will do that in this class. First law, first Newton's law of motion. The point is, what are these laws for actually? Remember that there is a difference between a theory and a law. A law has a proof, scientific proof, while theory doesn't have a proof. It's just a theory given by any particular scientist. Now, remember that all these three laws are associated with the explanation of the force which is being given by Newton. The Newton first law is what? If a body is in the state of rest, it will be in the state of rest. And if the body is in motion, it will be in the state of motion until resultant force is applied. Applied on it. Now, this is the statement that is for the Newton's first law. Now, what does it mean actually? I will explain that statement with the help of a example. Let's suppose we have a table, and on a table there is a book placed like that, right? Now, question is, that book which is placed on a table is in stationary mode, right? And it will be in the stationary mode, or it will be in the state of rest until you apply the force, or you can say unbalanced force, or remember that the resultant force, other names of that will be unbalanced force, or you can say net force, or you can say external force. All names to the resultant force. The question is, what is special happened when the resultant force is applied? Technically speaking, when you apply the force, the object start moving or try to start moving. So basically from here, we got a definition of a force, that force is an agent which produces or tends to produce motion in a body. This is the first part. But another part is, if a body is in motion, it will be in the state of motion. First of all, remember that on this very earth, you can't see this. The reason is very simple. If a body is in the state of motion, it will be in the state of motion until force is applied. On this earth, when the body is moving, you're throwing a ball, it will stop at one point. Reason is the force of gravity or air friction. These two forces are always acting on the body. If you remove these two forces, the body will move on and on and on and on forever. So, if a body is in the state of motion, it will be until the force is applied. So, the second part of that force definition is force is an agent that stops or tends to stop the motion of a body. This is the definition as per the Newton's first law. Now, important part is it's always there, tends to. The reason is very simple, because it may produce the motion or tries to produce a motion of a body, or it stops or tends to stop the motion of a body. Why tends to produce or tends to stop? Tends to produce means because sometimes if there is a wall and you're applying a force, it will not be able to produce anything, motion or whatever. The second thing is, if a body is in the state of motion, it will be in the state of motion until you apply the force to stop it, right? Sometime like van or a car, even if you apply the force, but it will not be, you will not be able to stop that. Now, there is a small thing which is here, because in the formula it's written resultant force. So let me explain it to you. What is the difference between a force and a resultant force? Let's suppose 2 Newton force is applied on the right hand side and 2 Newton forces applied on the left hand side on this box. These two forces are balancing each other, so we call them balanced forces. And due to the balance force, the net force is basically 0 Newton, or resultant force is 0. But as soon as you increase one side of the force, let's suppose this is 3 Newton and that is 2 Newton. Now, the resultant force will be on the right hand side, that is 1 Newton. So in that case, the net force or resultant force is 1 Newton on the right. That caused that object to move. So basically, the difference between the force and the resultant force is just a force. You are applying it. But a force that causes an object to move is called as a resultant force. A force that is sum of the two forces, factors of. Or you can say the force that is being balanced. After balancing, the unbalanced force left behind is called as the resultant force. So Newton is talking about the resultant force that causes the object to move. So he said when that force is applied, the object which is in the state of rest will be in the state of rest, and the object in motion will be in the state of motion when that basically force, that resultant force is applied, and it can change the state of an object, right? Now, another very important point in this case. Once we understand with the law that it gives you the resultant force explanation and everything, we should know that that law, the Newton's first law, is also called as law of inertia. Now, what is law of inertia? Law of inertia is very interesting because inertia is the property of a body. Now, what is that property? We will explain that through the Newton's first law. Newton's first law was saying that if an object is in the state of rest, it will be in the state of rest. And if the object is in motion, it will be in the state of motion until force is applied. My question to you is, if force is not applied, can I say that this particular object doesn't have an ability, does not have ability to change its state, right? So if that object doesn't have an ability to change its state of rest or motion, that inability, so the inability of a body to change its state of rest or motion is called inertia. And because this property is given by Newton's first law, so we also call that law as Newton's first law. So first law is actually giving us the definition of the force and also tells us that there is a property named inertia. Now that is all the explanation given by Newton's first law, right? Now, what is Newton's second law? Newton's second law is actually giving us the, you can say, the point through which we can say that it gives us a mathematical explanation of what exactly is the force. Or what is it? Let's talk about that. So basically, what is Newton's second law? Newton's second law is saying that force is directly proportional. I can say that. He said that if force is applied on an object, acceleration is produced in a body force applied is directly proportional to the acceleration produced in a body and acceleration is inversely proportional to the mass of an object. That is what the law is all about, right? Now, what exactly it means that? It simply means that basically that when the force is applied on an object, so what exactly happens? Let's see. When force is applied on an object, an acceleration is produced. Like for you, let's suppose this is an object, you're applying a force, right? Newton is saying when force is applied, acceleration is produced. And what is acceleration? Rate of change of velocity. So we can say that force is directly proportional to A. And if you remove that directly proportional sign, mass is a constant quantity that is coming up. And definitely because both are in product form, so acceleration and mass are inversely proportional. If mass is less, acceleration required needs more. Like if acceleration is less, mass will be more. So force is the product of mass and acceleration as per Newton's second law. What is the unit of force? Mass is kgs. Acceleration is meters per second square. So unit of force is kilogram meter per second square. This is called base unit. But remember that the SI unit of force is Newton. As the name suggests, Newton, scientist Newton gave his own name to this unit. All right. So this is what the Newton's second law is all about. He actually explained about it and that's why he put his name on it. All right. Let's do this question. Say a car salesman says that the best car has a mass of 900 kg. Mass is given and can accelerate from 0 to 27 meter per second. Initial velocity is 0 meters per second. Final velocity is 27 meters per second. In time is equal to t is equal to time is 3 seconds. Now they are saying find the acceleration for the 3 seconds. Now we know that acceleration is equal to final minus the initial velocity divided by time. So it will be 27 minus 0 divided by 3. So value comes is 9 meter per second square. And then they say force required to produce an acceleration. We know that F is equal to ma. Mass is 900 and this is 9 acceleration. So it's 8100 Newton. This is the force that is required to produce an acceleration of 9 meter per second square, right? So this is the application of Newton's second law. Now there is a Newton's third law. What exactly it is? It is also related to force. He said if one object applies the force on an other object, the other object applied the same amount of force on the first object, but in the opposite direction. What does it mean is, I will write another statement so that you will understand it. Action and reaction are equal in magnitude, but opposite in direction. The best example can be if one object applies a force on the second object. Let's suppose this is A object, this is B object. If A applies a force on B object, as per Newton's third law, B is also applying a same amount of force on A, but in the opposite direction. That is what Newton's third law is. Like the best example can be if you push the ground in the downward direction, as a reason or as a result, the ground pushes the feet of a human in the upward direction, and that's how we move. That is the best example of Newton's third law, right? So in this particular lecture, which is our lecture number 6 in dynamics, this is the first lesson, we have covered up all the Newton's law and everything, right? In the next lesson, we will be starting with Hooke's law, and related to Hooke's law, then we will proceed further into that. So hope to see you in my next lesson, which will be lesson number 7. And this is the end of lesson number 6. So student, hope to see you in the next lesson. Bye. Take care.